All right, hello students. So we're going to be solving by factoring today. So let's see here. We're going to be factoring trinomials. So we're going to start with some solve by factoring. That's kind of our main point of today. And again, this is going to be unit 4, lesson 3. So the first kind of vocab word we have is a monomial. And monomials are just single numbers, either a number or a variable. So it could be x, it could be 5, it could be x squared or b squared, whatever, okay? It's just kind of one single term or one single unit. Whereas a binomial is going to have two different terms. So it could be like x plus 7 or b squared minus 14, something like that. And then we end up with trinomials, which is kind of what we're going to focus on, binomials and trinomials today. So a trinomial has three terms that all have different exponents. So it could be like x squared plus 11x plus 28, something like that. So again, you have three separate terms. So we're going to focus on factoring trinomials in the form of x squared plus bx plus c, or our standard form. And so how I like to teach factoring is kind of using, when we're factoring trinomials, we're going to use the factor x. Factor trinomials. We're going to use this thing called the factor x. So the first example we're going to do is x squared minus 9x plus 20. So I'm going to make my factor x. And what I need to think about is I need to say, okay, I need two numbers that add to get negative 9, but multiply to get 20. So let's so again, my goal is multiply and then add together. So I'm going to say, all right, I know that they have to multiply to get 20 and they have to add to get to negative 9. So I'm thinking about all the ways that I can multiply 2 and 10, 5 and 4. Hey, I like this 5 and 4. And one key thing to note in this problem is I have a negative 9, but a positive 20. So remember, a negative times a negative equals a positive. So if I think about 5 and 4, that adds to get 9, but negative 5 multiplied by negative 4 is going to add up to get negative 9, but it's going to multiply to get 20. I'm just going to change the color. So this is negative 5, negative 4. So if I were to factor this out, my factor would be x minus 5, x minus 4. So my solution, so if all it said was factor, I would be good. I factored it out, x minus 5, x minus 4. Let's do one more example like this. X squared plus 3x minus 12. Okay, so I'm going to say, I'm going to create my factor x, which again, I want it to multiply together to be 20. So again, I'm putting my c value, the last value, in there. So I want it, in this case, I want it to multiply and equal negative 12. But I want it to add together and equal positive 3. So again, I'm pulling these numbers from right here, negative 12, and I want it to add together to get positive 3. So again, if you didn't believe me, if we jump back to our first problem, if I were to FOIL this out, so if I were to say x minus 5, x minus 4, multiply, 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 x squared minus 4x minus 5x plus 20, x squared minus 9x plus 20. I ended up with the exact same thing that I started with. So again, that's kind of our goal. So if I think about numbers that multiply to get 12, I have 1 and 12, 2 and 6, 3 and 4. I'm like, I think that I am having troubles figuring out how can I get something that multiplies to get negative 12 but adds to get positive 3. And again, if I think about the factors of 12, 1, 12, 2, 6, 3, 4, there's really no way that I can get that. So for right now, we're going to say that this one cannot be factored. Because, again, there's no numbers that can multiply to get negative 12 and add to get positive 3. Now, one of the special ones that we're going to talk about is a difference of two squares and a perfect square trinomial. Oops. So a difference of two squares looks like this. It's going to be a binomial. So again, difference of two squares. It's going to be a binomial, which means two terms. Its highest degree is 2. And it's going to have a subtraction sign. So what I want to do when I have difference of two squares is I want to take the square root of both of these numbers. So the square root of x squared is x. The square root of 49 equals 7. But I can't say x plus 7 because this is a subtraction sign. So again, the special part about difference of two squares is you have to subtract one of your factors and you have to add the other one. So when we multiply it out, I get x squared plus 7x, and then I get minus 7x, and then a negative times a positive is a negative. So notice this 7x here cancels out. All I'm left with is x squared minus 49, which is exactly what I started with. A perfect square trinomial looks like this. Okay, a perfect square trinomial looks like, okay, I've got, let's say d squared, it doesn't always have to be d, plus, or an x, excuse me, plus 36. So if I make my factor x, it's got to multiply to equal 36 and add to get 12. Well, I know that 6 times 6 is 36, and 6 plus 6 equals 12. So I could write this as x plus 6 times x plus 6, but it's actually the same thing. So I'm just going to say x plus 6 squared. And again, when you have the exact same thing like this, it's a perfect square trinomial. All right, let's keep going. And then, so again, if we want to talk about the zero product property, that's like kind of how we solve it. So zero product property, and all that means ZPP. Okay, all this is telling us is that, hey, if I have, say I have x minus 5, x plus 2, that was my factored formula, if I can get this x minus 5 in the parentheses, if I can get this to equal 0, 0 times anything equals 0. And it's the exact same thing if I can get x plus 2 to equal 0. Anything times 0 is going to equal 0. So I could set x minus 5 equal to 0 and say, hey, when x equals 5, this whole function is going to equal 0. Or I could say, hey, when x equals negative 2, this whole thing is going to equal 0. So that's kind of why we like to factor, is again, we want to find when these functions equal 0. And of course, you can use, you can check your work with a graphing calculator. So if I were to say, okay, let's say that we'll do, this will be kind of our last example here. Let's say I've got x squared minus x minus 12, okay? If I make my factor x, I say I want it to multiply to be negative 12, but I want it to add to be, there's no number here, but it's a negative. So I'm going to assume that that's a negative 1. So again, if I think about to multiply to get a negative 12, I could do negative 3 times positive 4, or I could do negative 4 times positive 3. Either one of those gets me a negative 12. However, only one of these adds up to negative 1, and that's this one. So I would have to choose negative 4 and positive 3. X minus 4, x plus 3, which again, my zeros would be x equals 4 and x equals negative 3. If I wanted to check that on my graph, my graphing calculator, I totally could. I could say x squared minus x minus 12. I get positive 4 and negative 3. Just for your own reference, again, if you get one of those perfect square trinomials, x squared plus 12x plus 36, it would look something like this, where again, you only have 1 0, okay? It only crosses your x-axis one time.